Displacement versus time. Displacement is a vector quantity, which means it has magnitude and direction which is different from distance. On this displacement versus time graph here, displacement is in meters versus time in seconds. Firstly, I can tell that from 0 to 2 seconds on the graph, there is a positive straight line shown, which means the slope stays the same for the 2-second period. In addition, since the slope of the interval is constant, then the velocity of that period must be constant. As a result, the velocity of this certain object is constant, which means the object is not accelerating. Then, from 4 to 6 seconds, I can conclude that the direction of the velocity has been changed and now it goes reverse from the original positive velocity. At this point, the displacement for the object is currently at -1 meter. Finally, the displacement for the graph will be 0 meters, where it equals to the final position at 9 seconds minus the initial position at 0 seconds. Velocity versus time. Now as the y-axis change from displacement to velocity and the units for velocity will be in meters per second. The slope of the object in this graph represents instantaneous acceleration. From 2 to 5 seconds on the graph shown, the constant downward slope represents a decreasing velocity at a constant acceleration. Then from 5 to 7 seconds, the slope becomes positive and goes upward, which means that the velocity becomes positive, which accelerates at a constant acceleration. Furthermore, not only by defining the slope of the velocity gives us the acceleration of the object, the displacement of the graph can also be determined through the area under the curves between the time periods shown. Now we can find the displacement of the velocity versus time graph from 2 seconds to 5 seconds by simply getting the area of the triangle, which shows the negative displacement of the object shown on the graph. Acceleration versus time. Acceleration is defined as the change in velocity over change in time. Since the acceleration graph is closely linked to velocity, we can solve the change in velocity by multiplying the acceleration with the change in time. For example, in order to find the velocity from 0 seconds to 3 seconds on the graph, we can simply multiply the acceleration 4 with 3 seconds time in order to get the velocity rate, which is 12 meters per second. Another way to do this problem will be basically just like finding the displacement for the velocity versus time graph. We can find the velocity in the acceleration versus time graph by finding the area under or upward of each curve of different shapes. These are both ways to effectively find the velocity in this time graph. Furthermore, the slopes found on this type of graph will give us the rate of change in acceleration, whereas second 1 to second 3 shows a constant and no change of acceleration for 3 seconds, which equals to 0 based on the graph shown. Thank you for watching.